Hello everyone, my name is Pisek, or you can call me Benz as well. I'm from Keston, and we promise to bring you actionable insights and tools to implement AI applications for yourself and your team. And this video's topic is about Docling, which is a very powerful document processing tool that allows you to implement multi-modal RAG. So let's get started. But first, don't forget to subscribe to our channel, Kiss Done by AI. We are on YouTube, LinkedIn, X, Substack, and GitHub as well. So let's open with RAG. What is RAG? RAG stands for Retrieval-Augmented Generation. But now we are in the multimodal world, meaning you want your knowledge base to be beyond just text. You want your knowledge base to encompass image, videos, audio as well. So that's multimodal. Today we are going to take a look at multimodal, where we will focus on text and images from a very popular document types, PDFs. So most of the time, your PDFs will contain text and images. Before we can implement RAG Chatbot, we need to process and create vector embedding database for our AI agents to retrieve information. For PDFs, most of the time when you load the PDF, you need to extract text, and well, maybe like 70% of the applications out there just ignore the images. If you want to implement multimodal RAG, you need to include your images, some kind of information in your processing pipeline somehow. So when we detect image, we can make some annotations, ask the AI to describe what image is, and just use that description to create what we call an enriched text. And this text is what we are going to use, convert it to a vector embedding, and keep it in the vector embedding database for our AI to reach. This is just one of the examples of how you can implement multi-modal RAG. The powerful tool that we are going to dive into today is Docling. Docling is an open source tool by IBM. It's very capable. It has internal way of dealing with PDFs, which is very, very cool. And also the repo allows you to extend to other capabilities that you think of. Maybe, for example, like the Word document, HTML file, or even the Markdown as a starting point. The idea of Docling is very simple. You have, well, a lot of file formats that you want to process. Docling provides you with a document converter. You can have standard PDF pipelines suitable for the PDF, which we are going to use today, or you can have other simple pipelines, or even define your own pipelines to process those documents. After converting it, you can choose to export it to Markdown, to Dict, or you can chunk using the hybrid chunker, and this will allow you to convert it to even LangChain documents so that you can implement a LangChain and LangGraph agent with it. By the way, we are going to have an open source repo here, so you can take a look at our code and how we do and use Docling for implementing the multimodal RAG system. So let's get to the demo. Here, if you go to our repo, you will see notebooks here. We are going to go through 3 notebooks today. The first one, which we are going to do it now, is going to provide you with a basic of what Docling is and its capability. Our document is kept inside this folder. We are going to process this file only. So what does it look like? It is this file. This is a technical report from Docling itself. I just take only a few pages out of it. And you can see right now we have text. We also have image right here as well. And this is what we are going to take a look at in particular. This image is around headings 3.1. And you are going to see that we are going to make annotations with the help of OpenAI later on. Back to this notebook. Without any customization, you can already run the converter the basic converter, document converter, is going to convert your PDFs into text. Behind the scene, the algorithm is detecting text location of any characters in the PDF pages, weave it into a coherent story as much as you can. This is now the markdown converted from the document that is processed before. And you can see this kind of syntax that instead of, well, at the beginning, we have this logo. Now it's recognized it and it marked it as an image right here. So if we actually look deeper into heading 3.1 right here, this corresponds to this image. And as you can see here, the vanilla conversion process just annotated as an image without any other explanation at all. So if the document doesn't have a very good description of what this figure represents, the meaning would be lost. So you might want to implement a non-vanilla version of the conversion process to annotate or describe or put a caption to the figure. And this is what we are going to do next here. So Docling is flexible, as I mentioned. You can add on a step during the PDF conversion pipeline so that the image, which is recognized by Docling, that image will be sent to OpenAI to describe it back. And this is one of the way to do it here. You are going to use one of the options here is the picture description API options. I am going to call OpenAI, and this is the text prompt that will go along with the image. So you provide this option inside this Docling PDF pipeline options. So basically, when the PDF pipeline is triggered, one of the steps will be sending images along with this to OpenAI. Right now, I'm using GPT 4.1 mini to do a captioning. And we are going to get the captioning back. And during the serialization or converting to Markdown, you will see that the annotation now is provided in the enriched context. And now we are just going to run exactly that. So I'm going to run this function. Now it's processing the PDF. I am just going to export it to Markdown like before, and then we are going to see the difference. Here we go. We are going to go to the section 3.1 right here, section 3.1, and you can see here, this part is the annotation that we received back from OpenAI, and it's the description of what that image is. For example, this is it. The image represents a workflow diagram for processing PDF documents. It begins with the PDF file and so on, which is very well reflecting what this image is. So essentially now you have what we called an enriched document, which can be ready to convert it to vector embeddings kept in the vector embedding database so that the agent can retrieve information back when we use the agent. One of the things that I think I like is with the Docling repo, you can choose to convert at the end, after converting the PDF, you can choose it to save it into a Markdown file with external references. For example, if I run this file, it's going to save the document in Markdown format, but also save images, keep it external outside of that Markdown file so that Markdown file can reference it. And you will see something in the output here. Here we go. So this is the exported Markdown. And you can see that it has an external references to this right here. Look at that. It's located here. Now, why do I like this? I like this because you might want to have access to the images in order to do other types of RAG pipeline. You might have another vector embedding database where you can actually keep the vector embedding of the image itself. Rather than just the caption, you can embed the image itself and keep it somewhere as well. So now with this export function, you have means to use the image of the PDF later. This is it for the basic of Docling. I think it's a very powerful PDF processing pipeline, but it goes beyond PDF because it can support other types of documents like Word document, PowerPoint, or even HTML files as well. All right, so what does it look like in real life? So let me start with the second notebook. What we are going to do here is we are actually going to process folders. Folders contains PDF documents, and we are going to process it and create vector embedding database for our agent. For those embedding database, I choose to use Milvus for many reasons that I'm not going to cover here, but this is the Milvus server run on my server right now. And when we process the indexing steps of RAG, the vector embedding database will be created here later for you to see. Oh, by the way, when I make this repo, all the configurations that is needed for creating the multi-modal RAG is kept in here. For example, whatever is related to the model, I put it here. For Docling processing, the configuration is here as well. Maximum tokens of a chunk is here. For vector embedding database, when I use Milvus, it's here. This is the access to the endpoint of the Milvus database that I am going to use. The collection name, the default is collection name demo. I can change it later. The name of the database can be changed as well here. This file basically contains configurations of this application. So I load the configuration here. Now in this folder, there is only one document here, but you can imagine that we can have a for loop when we process the document. This step is going to show you how to convert a document with the code that we have here. We have code inside the index, which is responsible for functions related to indexing documents. That includes process the document with Docling, as well as use Milvus as a vector store and use embedding models, for example, the text embedding small from OpenAI to convert text chunks into a vector and will be kept inside the vector embedding database, Milvus ones. So we are going to load the configurations, provide choose a chunker. A chunker is another element that Docling provides. It helps you create chunks basically. You can define how many tokens you want in a chunk. Right now we are going to use like 512 as the default value, and this is just the PDF processing pipeline that you see before. And I have one function inside the index which allows me to process the document. Here we go. Nothing fancy. I'm just using a Docling converter right here. So with this, it's going to provide me with a converter, and we are going to process the first file only, and you'll see what docs is. Docs will be process document chunked properly according to our configurations here. In this case, we have 9 documents just from one PDF, and these 9 chunks are like this. This is the first chunk. This is the second chunk. So basically what happened here is the PDF, this one, got loaded into text and images. Images got sent to OpenAI, and we received the caption back. Caption is inserted into the text. Now we have enriched text. The enriched text is now chunked into pieces, and that's what we see right here. And this is ready to be embedded and keep inside the Milvus vector embedding database. Well, that's the basic of it. But now what I want to show you further is, imagine you want to create many folders for keeping different topics of knowledges. And my repo allows you to do it just that. You can set a configuration to change the collection name. For example, if I want to process folder 1, I might change the name to something appropriate. Let's say right now, folder 1 DB. And then I trigger this function, process an index directory. It's going to go through the files inside this folder and process it into the vector embedding database. And here, this is the first one that we are going to do. It's going to take a while. And once it's done, now it's indexing 9 documents, and now it's successfully added to the Milvus store. And if we refresh this, we are seeing this one now. All right. And this is data, chunks, and related embeddings kept inside this vector embedding database. And we should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now, I can do the same with another folder, another knowledge topic that I want to keep. I just need to change the collection name and provide this function with the folder we want to trigger. Here we go. And it will be ready in tens of seconds. Right, so we're almost there. So 51 documents is created by one PDF. This one is a PDF from Mackenzie. So now one PDF is converted to 51 documents. And when we refresh this page, we are going to see this document, vector embedding database, right here. And this contains all the information from that PDFs. Now we are done with the indexing step, which is the first step if you want to implement a RAG system, whether it's a basic RAG or a multi-modal RAG system. Now, for the last step that we are going to cover, we are going to quickly show you Agentic multi-modal RAG. I'm not going to dive into the code right now. It can be for another video. I just want to show you what is possible. Or you can explore the code at agent.py over here, where the agent is divided here. And if you go into the build, which is responsible for connecting the graph itself, you can make sense of it. But anyway, you will see a graph after I run this. So let's first prepare our vector stores. As you can see here, I have 2 vector embedding databases. I want to be using it as 2 separate knowledge. So we are preparing 2 vector stores, vector store 1 and vector store 2 for the agent. Vector store number 1 will access the collection name, will access this collection, document 1. And this is supposed to be knowledge about Docling. Now for vector store number 2, it's going to access this collection name, doc2db, which is supposed to be Agentic AI for its topic. And you can notice that I need to specify this name and description appropriately, because this is going to be used for the agent to understand what tool or what retrieval knowledge, the vector embedding database it is. So name is the retrieve documents on Docling for the first vector store. And this one is retrieve documents on AI, Agentic AI for vector store number 2. Now we provide lists of vector store for this, and we are going to create an agent by calling this class like so. Now I am going to run it, and the agent is now created. And this is what it looks like for LangGraph. When we send human message in, it will go to this node first, and this node will determine whether we should use the retrieval documents for Agentic AI or retrieval documents for Docling AI. Once it has retrieved documents back, it will determine whether is it sufficient to generate an answer. If not, it's going to go to the rewrite question node, which is going to be back here. It's going to form a new questions or query in order to determine whether it needs to use a tool. And this is what the agentic RAG is. It reasons itself whether it has enough information to answer or not. Otherwise, it's going to keep in this loop until it can terminate itself somehow. All right. So this is what it is. We can send it a questions, but you know what? Let me demo with a user interface. I have here another module UI where I kind of like tweak Gradio a little bit so that it shows me what I want. All right, so we have a chatbot ready. I can say that, hi, Benz, who are you? All right, yes, because we are using OpenAI, it knows itself that it is ChatGPT. Tell me more about Docling. What's it for? This is about Docling. So it's supposed to use retrieval document related to Docling. And here it is. It's using retrieval documents on Docling tool. And once it has enough retrieved documents back, this is the answer that it provides. Okay, now tell me more about banking retail and how it needs agentic AI. Now the agent, the AI, will need to switch to use the retrieval tool related to the agentic AI topic in which we provided already. Here we go, retrieve documents on agentic AI. So it has some reasoning ability to choose the tool that is relevant to the questions right here. And this is the agentic AI. Even though we are not going to show you a full agentic capability, agentic AI will keep going into the loop. We haven't met this node yet, but with proper coding and proper query, we should be able to get there. But this is not the topic of today. So essentially, what I've shown you today is that if you want to implement multi-modal RAG, you can use Docling to process PDF documents or documents that is filled with text and images. You can ask Docling to provide annotations for the images and use that annotations in the enriched text. But Docling also has ability to save image as references so that you can improve the process by maybe use images to create embeddings for search later. So this is all about Docling for multi-modal RAG implementation today. So before we leave, don't forget to subscribe to our channel, Case Done by AI, or you can share it with your friends, whether it's your boss, your managers, or your teammate as well. See you in the next video. Thank you very much.